Welcome to our YouTube channel. Another day, another skill. In this video we are going to discuss the specific gravity and density. Specific gravity and density are both measures of the mass of an object or substance, but they are not the same thing. Density is defined as mass per unit volume. It is a measure of how much matter is packed into a given space. The units of density are typically mass units, such as grams or kilograms, per volume units, such as liters or cubic meters. For example, the density of water at room temperature is approximately 1 gram per cc, gram per cc. Specific gravity, on the other hand, is the ratio of the density of a substance to the density of a reference substance, usually water at 4 degrees Celsius. Since it is a ratio, it has no units. It is a measure of how dense a substance is relative to the density of another substance, and is often used in industry and scientific applications. To illustrate the difference between the two, consider a material with a density of 2 grams per cc. If we compare its density to the density of water at 4 degrees Celsius, which is 1 gram per cc, the specific gravity of this material would be 2 over 1 equals 2. So, the material is twice as dense as water. Density is an absolute measure of mass per unit volume, while specific gravity is a relative measure of density compared to a reference substance. The main differences between density and specific gravity. Definition: density is the mass of a substance per unit volume, while specific gravity is the ratio of the density of a substance to the density of a reference substance, usually water at a specified temperature and pressure. Units. Density is typically measured in grams per cc, gram per cc, or kilograms per cubic meter, kilogram per cubic meter, while specific gravity is a dimensionless quantity, meaning it has no units. Application: density is a fundamental physical property that can be used to determine the weight or mass of a substance, while specific gravity is often used to compare the densities of different substances or to determine the concentration of a substance in a solution. Temperature dependence. Density is affected by changes in temperature, while specific gravity is typically measured at a specified temperature and is less affected by changes in temperature. Calculation. Density is calculated as mass, volume, while specific gravity is calculated as the ratio of the density of the substance to the density of the reference substance. Range. Density can vary widely depending on the substance being measured, while specific gravity is typically between 0.8 and 2.0 for most substances. Overall, while density and specific gravity are related properties, they have distinct definitions and applications, and may be more or less useful depending on the specific context and purpose of the measurement. Subscribe to our YouTube channel. Press the notification bell. In rubber compounding, both density and specific gravity are important properties that can affect the performance of the rubber compound. Density can affect the weight and volume of the rubber product, as well as its mechanical properties. For example, a rubber compound with a lower density may be lighter and more flexible, while a compound with a higher density may be heavier and more rigid. Specific gravity is also important in rubber compounding because it can help determine the composition of the compound. For instance, specific gravity can be used to determine the amount of filler, such as carbon black, in a rubber compound. By measuring the specific gravity of the rubber compound and comparing it to the specific gravity of the filler. Overall, both density and specific gravity play important roles in rubber compounding, and their measurement and control are critical for achieving the desired properties and performance of the rubber product. In rubber compounding, the properties of the rubber compound are influenced by many factors, including the type and amount of raw materials used, the processing conditions, and the curing process. Density and specific gravity are two important properties that can significantly affect the performance of the rubber compound. Density is a measure of the mass per unit volume of the rubber compound. It is an important property because it can affect the weight, volume, and mechanical properties of the rubber product. For example, a rubber compound with a lower density may be lighter and more flexible, while a compound with a higher density may be heavier and more rigid. Specific gravity is the ratio of the density of a substance to the density of a reference substance, usually water. It is an important property in rubber compounding because it can be used to determine the composition of the rubber compound. For instance, Specific gravity can be used to determine the amount of filler material, such as carbon black, in a rubber compound. By measuring the specific gravity of the rubber compound and comparing it to the specific gravity of the filler material, the amount of filler in the compound can be calculated. In addition, specific gravity is often used to determine the concentration of certain chemicals in a rubber compound. For example, if a rubber compound contains a solvent, its specific gravity can be measured to determine the amount of solvent present in the compound. Overall, both density and specific gravity are important properties in rubber compounding, and their measurement and control are critical for achieving the desired properties and performance of the rubber product. Like, comment and share this video with your friends and family. For better understanding, please watch the video until end. Here are some additional points to keep in mind when measuring rubber density and specific gravity. The rubber sample should be free of any surface contamination or moisture, which can affect the accuracy of the measurement. The pycnometer or other measuring device should be clean and dry before use, to prevent any contamination or interference with the measurement. It's important to take multiple measurements and calculate an average value, to ensure that the measurement is accurate and representative of the entire sample. If possible, it's recommended to use a standardized method such as ASTM D29793 or ISO 2781 to ensure consistency and comparability of results. The specific gravity of a rubber compound can vary depending on the specific ingredients used, such as fillers, plasticizers, or other additives. Therefore, it's important to measure the specific gravity of each component separately, as well as the final compound. The density and specific gravity of a rubber compound can affect its physical properties, such as its strength, hardness, and elasticity. Therefore, it's important to measure and control these properties during the rubber compounding process to ensure consistent quality and performance of the final product. We will see you with another video.
Thanks for watching.